I guess that they cannot unmute themselves. So
Okay,
let's go.
that's all right.
Yeah.
That's all right. Prabhu heads up architecture and engineering in Avesha, and JD is our resident expert. Lots of Kubernetes, huge experience. So he's always been helpful for us to define it. Right. So I have all the power here. If I go, if I screw up, there people who are going to help me.
Yeah, don't worry, don't worry. Anyway, we were able to. You can unmute yourself. So if you would like to introduce yourself, would be great. Let's see.
All right. Marcelo is back.
Yeah, Marcelo is back. Anyway, okay. So I am already recording. So let's try. This is the good one. So hey, everybody, nice to meet you. Although the technical issues we just faced with Zoom, I'm really happy to be here, and we did it. So we are here with Prasad from Avesha, and I'm really excited because as Dario, I'm part of CLASTIX, and CLASTIX is a startup that is trying to build more awareness regarding multi-tenancy in Kubernetes, because it's a hot topic. And the first time I saw KubeSlice, I was really interested on their way to address multi-tenancy, because there are so many phases of multi-tenancy, and I'm really happy to be here and introduce Prasad. So Prasad, please introduce yourself for the second time, but this is the right one, so go ahead.
Thank you, Dario, and thank you, Marcelo, both of you coordinating and having us present our solution. We really appreciate it. I think this community at large is looking at, how to address some of the Kubernetes, as I call it, multi-tenancy is not a first-class citizen in Kubernetes. Right, so it's all defined in cluster, and then there are reasons why people would want to do multi-tenancy. It'll be interesting for us to, as a community, to understand what are all the different use cases. Some of the use cases which we are seeing is what drove some of our thought process and how we defined a KubeSlice. I run product for Avesha, and as well as, there are team members from my organization which are also on the call. And if I, the hands-on guys are also there, so it'll be helpful. So without further ado, and let me explain, everybody is trying to go into Kubernetes because of development velocity they would want to get, and containers is the way of doing it. And then when you do microservices, there are hundreds and hundreds of microservices which are built into it. Kubernetes is the de facto standard for orchestration for all the containers. Everybody is converting there. I mean, 70+ % of enterprises have already converted or working in some form of Kubernetes, right? The challenge is twofolded. One, cluster sprawl is a real thing, right? How many people are spinning up different clusters? I used to run an operations team where CISO used to be in my organization, and security is paramount important. So I keep saying, before you do any good, don't do any harm, right? So we don't want the enterprise to show up on a newspaper saying that it got hacked, right? So security is foundational for everything. Now, just because the clusters are bigger and bigger, sizes from a number of nodes you can have and all that stuff, you need to have proper guardrails inside the cluster. If you do small clusters, then the cost is quite high, because everybody is going to put some scaffolding with respect to what is inside the visibility, and the control plane is not simple, right? And suddenly what became an experiment in a dev shop now turned into a production. cluster. So they don't have the right RBACs in place. They don't have, and then people are trying to figure out when something pops. You need to go get a right framework in place. So those are all challenges from an operation standpoint. Looking at that angle, we came up with a bunch of network services which are necessary for isolation, and as well as Kubernetes services which are out there from a network policy, and as well as RBAC and other things. So that is the culmination of all those things is what KubeSlice is. Not only do we address a single cluster in KubeSlice, we also address multi-cluster scenarios. There are reasons why people are trying to do multi-cluster, right? Be it edge adoption, or be it from a resiliency standpoint where they want to have multi-region, or be it multi-cloud because of there are clouds which are very specialized on certain things. Like for instance, OCI from an Oracle standpoint, they have licensing issues with Oracle, so they want to have Kubernetes on OCI so that they can still use Oracle. There are ML kind of workloads which are very specific to GKE or Google-based things that people are going to use some of the workloads there, right? And then there are Azure guys who are trying to use some of the Microsoft kind of packaging and other stuff. So that's the reason why. So any which way you look at it, you want to have multi-cloud. But how do you extend multi-tenancy to multi-cloud is what we address. And then how do we address it from a networking standpoint, network services, which you need to bring to that, and as well as application needs, what we do. That is what KubeSlice is. So in a landscape, where do we fit? It is very important to understand, right? Where do we fit in the Kubernetes landscape, right? There are API gateway guys who are building API gateways and stuff like that. How do you get into the Kubernetes cluster? And there are ranchers, Spectral Cloud, OpenShift, Tanzu, and others who does lots of life cycle management, which I call it, or managed services for customers, right? And then there is this new breed of service meshes, which do service-to-service communication from a standpoint of whether you want to have a sidecar-based envoy to give you visibility, or MTLS and traffic steering and other stuff, which is kind of what service mesh offers. And then CNI of the world gives you the addressing from a standpoint of cluster pod networking and node networking and other stuff. What we are is we are at the bottom of the pyramid, which is supporting anything on top, right? Which is essentially bring in multi-tenancy natively in Kubernetes, and then as well as multi-cluster connectivity natively in Kubernetes to be extending that tenancy across multi-cluster. Right, so that is what KubeSlice is. KubeSlice is an open source. If you go to github.com/KubeSlice, there are all the repos are out there. You can try. There are different charts, and then you can also join like you guys, CLASTIX and others. We all complement each other in a different way. So we address certain things and then use case basis. You can also join us in the Slack under Kubernetes channel. KubeSlice is the channel on the Kubernetes organization. So those are all ways to reach. But let me describe a little more about what we solve, right? What we solve is securely connecting applications across multi-cluster in a tenancy way, right? So that is one thing, and then as well as observability, right? Without knowing what is underneath the hood, it is important. Operationally, it is terrible to have running a cluster without much of observability, right? When shit hits the fan, pardon my language, So you need to find the root cause, right? And then fix it. In order to find the root cause, you need to know where exactly the problem is. How do you know all of those things are important, right? And then tenancy is definition of tenancy to me is an isolation principle, right? Isolation from access, which is RBACs, isolation for network, which is essentially to say that, how do we, so Kubernetes by definition is one flat network, right? And then people can, infiltrate into one of the hosts, and then they can traverse anywhere. So the security is very paramount important. Although we give network policies and other stuff, but so there are certain limitations with respect to how people use those things, right? So that is something. And then when you go into multi-cluster scenarios, and then say, for instance, you have created a namespace and then associated an RBAC in a cluster A, and then you create another cluster B from a capacity standpoint. Do you go create the same kind of RBACs rules and the config drifts and all that stuff is a challenge, right? Things do happen in the things, and how do you automate all of that? So those are all the foundational things. And then our strong belief is one which we think is every enterprise is trying to become a SaaS provider. When you are a SaaS provider, right, your reach of your solution is global. And you have customers all over the place, around the globe. You don't want to centralize the services in one region and then offer the services in different places. So you want the distribution of workloads. When the distribution of workload happen, how do you connect them is foundational, which is very necessary for multi-cluster scenario. But given that multi-cluster scenario doesn't mean to say you have to ignore the multi-tenancy aspect, right? So that's the thing which we automate. So at a high level, in a pictorial way, if you look at it, KubeSlice is slice is a CRD, which is an abstract which combines multiple namespaces together across multi-cluster environment, and then bring some network services and Kubernetes services together to form a tenant, right? So that is something which you have to take, it's a takeaway from that, right? So the architecture is, obviously, we are all telco people coming into this, so we need to have a control plane, which is different from the data plane or the worker plane, what we call it. So there's a reason why we have a controller, which is essentially a lightweight Kubernetes cluster. It can be separate or it can be together, but in most cases, we would want them to deploy it separately, because that is something which you don't, all the configuration is sitting there. Very little of proprietary information is there. Most of it, we use it in etcd and use that way, right? It's a CRD from our standpoint. And then the worker clusters are something which we have, which is essentially where we bring the network services into it, right? So, and you can have multiple slices in a cluster. Like as I said, multi-tenancy. Tenancy is a slice. So the genesis of slice came from the word. In 5G world, there is something called a network slice. In a network slice is a way to offer networking, sharding of a network to an enterprise, private enterprise and all. So what we saw is the parallels of that in the application side. That is the reason why we call it KubeSlice, which is an application side of that nature, right? So I think I don't want to bore. I think everybody understands what are all the noisy neighbor problems in the single cluster or across clusters, commingled traffic from a standpoint, and then policy drifts and all that stuff that needs to be addressed in order to do this, right? So, different observability aspects, multi-isolation, which we talk about. Anyway, I'm going to, when you have this video, you can always stop the video and then see the words. But let me go back to what I'm going to demonstrate, right? I'm going to demonstrate this scenario, right? Where I have a cluster in AWS. That is where my controller is running. I have a cluster in GCP, GKE, and I have a cluster in AKS, right? And then I'm going to create a tenancy in GCP and extend it to Azure, right? And then distribute the applications across those two clusters. And then we also have somewhat of a service discovery and all that stuff. We will show you how that works. But from a multi-tenancy standpoint, we establish the tenancy using across multi-cluster on a networking sense, and as well as network policies associated with it, and then RBACs associated with that, right? So that's the kind of isolation which we will show, right? You would see the multi-cluster management and as well as tenancy across all these, tenancy management from a single cluster, right? So let me just stop for this slide and then go back to any questions so far?
Yeah, keep in mind, Prasad, that I'm watching the chat. So also people, if you have any question, don't hesitate to write that, and I'll try to collect everything. And we are going to have also a QA session at the end.
Sure, thank you. I'm going to share this terminal.
Yeah, go ahead, Prasad, also because I got a lot of questions. So if the people here is shy, don't worry, I can take care of that. So I got plenty of questions.
All right, I'm all for it. So as I said, right, so there are a bunch of aliases which I have, any Kubernetes guys will do the same thing. When you see some funky commands, it is nothing other than just aliases. I don't want to keep making mistakes and typing certain things, right? So KCTX will tell me that I have a controller. So I do C1, then I change my controller. So our architecture is that we have a construct called project, right? If you look at KNS, the different namespaces, there is a controller namespace, and then there is a project namespace, right? The KubeSlice demo is the project which we have today, which we are doing. Right, if you KNS to that's just the reason why. So there is a project. A project can have multiple clusters across multiple, clouds. Right, and project definition is project is a CRD, right? And then that project will create its own namespace inside the controller, right? Right, demo in, and then if you see, each project can have multiple slices, right? And then if you look at right now, I have created 2 slices, right, for the demo. There is a slice called meetup demo, and then there is a slice called meetup Istio demo, right? How does Istio work on the tenancy, and as well as how does normal microservices work in a cluster, right? So that's the thing, right? And then each one of them, the controller is managing these 2 clusters. Cluster worker 1, which happens to be in GKE, and worker 2, which happens to be in AKS, Azure, right? So when you go back to cluster 2, which is essentially that, right? Okay, if you look at the KNS, I have, if you do get slices, slice minus n cube slice system, it tells you that there are two slices which are out there, right? Okay, describe slice it tells you that it has an overlay network, and then there are different IP addresses which we are. So if you look through this, right, let's say I will do, there is a namespace called iperf, kget pods. If you look through, there are iperf server is a typical, for a throughput standpoint, we use iperf client and a server. There, it's a daemon, I mean, it's a replication set, right? It has 3 replicas, right? Pods minus O wide. If you look at it, it has its own pod IP network, right? 10.7. something, 10.7 something. But if you look through that, every pod on a slice will also have another additional interface. This is the pod networking interface, and this is the application networking interface, right? Which is essentially an overlay network. This is what we use to communicate across multi-cluster, and as well as inside the cluster if you would want to, right? So now what happens is, if you look through this, and then if I say minus A for all this thing, right? If you see, right, let's say I'm not going to say minus A for minus N for book info, and then remove minus A. So there is in book info, right? This is 1.9, right? Is the same address as what you have for on the same cluster for one of the pods for the iperf server. So because of those two slices, we share the same IP addresses across multiple slices. So now the challenge to have pod networking IP address multiple times is not there anymore, right? You can have the same address space. Now you can extend it across multi-cluster. So in the multi-cluster scenario, this tenancy will have the same overlay network. So literally, you have created a virtual cluster across multiple Kubernetes clusters, right? So that way, it is still have a flat network per slice across multi-cluster. Okay? And then what we do is we enable network policies to isolate all of that. Now, naturally, when you have conflicting IP addresses, you don't even talk, right? So essentially, that would one way of protecting that. Anybody has any kind of addressing scheme, they would not be able to talk across same address spaces, subnets, and stuff like that. So that is one way of protection. Other way of protection is on the CNI side. We we offer network policies by default by coming in by slice. By the way, in a slice, it is not a single namespace. You can have any number of namespaces combined into that, right? So that you're not just bound to a single namespace per tenancy. You can have multiple namespaces together. And then we don't change the The only distinction between Capsule versus us is that we don't change the namespace name, right? The namespace is what they have, whatever they have, they will use that. But we are using network to isolate them rather than more on the namespace side, right? So that's one thing which we want to do, differentiation. But each one has its own use cases, right? One may be different in different use cases. One may be different in other use cases. Our use case is more centric around telcos would want to have flat network across multi-cluster because they want to have not just a layer 7 or HTTP traffic. They want to have anything from layer 3 and above, right? They have exotic protocols which need to be passed through, right? They need to have some level of transport, and then that transport is what we give in the tunnel sense, right? That's something which we do, right? From a networking standpoint. That way it is easier for them. But from a tenancy standpoint, we maintain the same RBACs associated with it. We also offer same nameness across multi-clusters. So you create one namespace and then say same nameness need to be applied. So as long as whenever you create a new cluster, that and add that slice onto that cluster, automatically all of those things will be propagated, right? Which with that propagation, they also propagate the RBAC rules associated with it, so that you don't have to really, you need to look at the cluster creation as a template from a lifecycle management standpoint, and anything above on an application sense is something which we always take into consideration, right? So that is one thing, right? If you describe, netball, I would do it for book info. That will be interesting for you. What I wanted to bring to bear is this, right? So we have a concept called allowed namespaces, right? If you have certain set of namespaces which are not part of a slice, like for instance, you have a centralized logging mechanism, or you have ingress coming in into the cluster, or you have a kind of a secure area for your security people to keep monitoring all that stuff, which is not part of your slice, which is not part of the tenancy, but you're kind of allowing specific set of namespaces to be talked across. You allow those things through allowed namespaces, right? Say for instance here, I have in this slice we have kube system, because lifecycle management and all that stuff is necessary. Istio system and ingress is allowed, so that this slice can have ingress coming in, right? Take this the same thing, and then if you look at meetup demo slash iperf minus n iperf. If you look through that, right, you in the iperf slice, you're not allowing any ingress coming in, right? So you have a choice as to what cluster you would want to have and how you want to have. If you look at the manifest file for slice creation, right, I'll explain that from the manifest file. What we are saying is, what is the slice of the name? This is the CRD, which we have. What's the subnet, which is necessary for your slice across all the clusters, any number of clusters, right? What are the tunneling protocols which you use across the clusters, right? We also do IPAM management, IP address management for all the pods coming in, right? As and when the pods come in. And how many clusters you would want to have on this slice to be. You can have any number of clusters you want to be on a slice. Right now, this is only two clusters, which we have. And then we have traffic shaping in between the cluster traffic, right? What is the QoS associated with it, and how do we give the traffic? And then look at how many namespaces you want to be onboarded onto a slice. You can have any number of namespaces. Is it on the same cluster or different clusters? If you have different namespaces on different clusters, you can use that for cluster basis, right? And then what are all the namespaces you want to allow? It's like a pinhole to a firewall, right? How do you allow a certain set of traffic coming in from an ingress and egress standpoint? And then if you enable gateways to talk across, right, be it ingress or be it egress, and then we are also cognizant about how service mesh works into play, right? Those are all the things which we configure, and then you provide that to a controller, and the controller would push it to all the worker clusters automatically. So you don't have to do anything, and then literally all those configuration is configured across multi-cluster scenario, right? So that's, I mean, I can go details, but I think we are running out of time for questions. So why not we stop there and then ask more questions for us? By the way, the deployment of applications is nothing, right? So applications will not change anything, right? If you look at product page.yaml, right? A typical product page, right? Well, one thing which I forgot to mention is that we also support service discovery and service export and import across multi-cluster. Just because we are multi-cluster, right? We also imported, reviews page. If you look at it, we have a small section where you export services from one cluster to another cluster, right? And literally, it's a full mesh, right? Every cluster now on that slice only, on that namespace only, which is the tenancy, you can see the services. So literally, if you KCTX, we are in cluster one, right? Get service import. What was imported onto it? All the services are imported. If you look at kget pods, there is only one product page pod, but when you go into product page, it automatically works. So I'm going to show you. While you ask questions, I'm going to show you the load balancer aspect of it through Project and Envoy, right? I have to share a different screen now. This is a problem with the, if I have a larger screen and.
Don't worry, no problem at all.
Yeah. So literally, if you look through the traffic, it is going from, no, I don't want to do this. Yeah, I want to share this. So that IP address I shared, and then I put a product page, boom, it comes into the slice, right? It comes right, we use contour to come in to a slice. And then just because we allowed that namespace, if you take that namespace, allowed namespace off from that slice config, then slice is totally isolated. Nobody can come into that, right? So that's the kind of a framework which we have. I think I have only 10 minutes. I might stop and then take questions.
Yeah, don't worry, Prasad. If you want to continue the demo, there is no problem. Since also because we started late due to my fault. No offense to anybody, but I got a question, so let's try to break the ice.
Also, we have a question from one of our guests. I'm very sorry, I'm going to butcher the name. Niljan Mana has a question for Prasad. What happens if there is a disruption of a network between two slices? For example, the VPN tunnel B/W, the slice routers, is disrupted and becomes unreachable.
Yeah. So Nilanjan, we have redundancy per gateway and the routers, right? We bring in our own routing element inside the inside a slice. Slice will have its own. Hold on, let me just share. Right. You guys can see it. KNS. So in this configuration, just because I have a smaller setup, I did not look at it. But if you look through this, there is a router per slice, right? Each one has its own router. And then there is a gateway per slice, right? And then gateway is coming to connecting multi-cluster. So if there is any disruption, you can deploy that into a highly available format. So what we do is kget nodes. So kget nodes minus show labels. So you deploy the node with the gateway label. I don't know. There are too many labels inside that I can't find it. But if you say gateway node label is label equal to gateway, those are the nodes where you deploy your gateways and routers and all that stuff. So the preferred way is to always have redundancy. In the demo, we didn't want to show the redundancy because it is easier not to show much. So that's what happens. And then everything we take care of with respect to route management and as well as tunnel creation automatically happens. Nilanjan, I hope it answers your questions.
I think so, and I'm really happy because I see other questions. And let's continue with that, if you don't mind, Marcello. I'll steal you the MC. So which VPN implementation do you use to bridge the clusters? How much overhead does the VPN add from Luca, from Italy, I guess? Yeah, pretty sure.
Yeah. It's OpenVPN is what we use, and it is it is not a whole lot from a performance standpoint. We did profiling with respect to that. So there are different ways. We can also use WireGuard and other set of things. So it's not this is in this implementation, we're just showing one.
That's great. I wasn't able to unmute myself, so thank you. And the next question is, does Slice router uses IP tables? Huh.
No, it's a VL3 router, which does not use any of the IP tables on a node, right?
Okay. And I got a question from my side. I saw that you're using a project CRD and a custom resource definition for the project. And the question is that custom resource cluster scoped, or is it living in a namespace? I mean, the instances, which is the scope?
Yeah, currently it is cluster scoped, but we will eventually make it to a namespace. But Slice part of it is cluster scoped, right? So we will, there is a roadmap item to make it on a namespace scope. Yeah.
And since we are here, another question. So maybe I missed, I didn't follow, I didn't pay so much attention to the presentation, so my bad, shame on me. But I didn't get if you're totally transparent and agnostic to the CNI or not.
So we are agnostic to CNI. Right now we use Calico, but we can use Cilium or any. So the only dependency on a CNI is somebody who actually does network policy. So AWS CNI has some challenges with respect to network policies, right? So we expect that in a CNI which has the network policy proper implementation, I think we will work well. That's the only dependency.
Yeah. And the next question, and it's a bit spicy, you know, is that Cilium is the new shiny thing out there because they are using eBPF, heavily eBPF, and they're claiming a lot of superpowers, multi-TLS, and also multi-cluster management. Oh, well, multi-cluster, not management, sorry, but multi-cluster connectivity. So the spicy question is, what's the difference between KubeSlice and Cilium using the multi-cluster feature?
So it's important to understand the distinction between when you create a cluster and then when you create a slice, right? So so typically when you have a multi-cluster, I mean, you have a clear plan as to what it is. What if you have multi applications distributed, and then you want to use some way of creating a flat network, right? So in our case, we say, I don't care what your pod network is. So the pod network can be whatever it is. So you templatize your cluster creation. Think about it in a scenario where I am actually talking to an edge scenario where edge is a managed service and edge is something somebody doesn't have an eBPF in it. How do I connect that? How do I connect data center versus address plan in data center versus AWS? How do I connect AWS to GCP? So the IP addressing is very, very fundamental for service-to-service communication from that, right? That is what we are creating by creating an overlay network, and we remove all those challenges of addressing the IP address planning and other stuff. That is what we are different from eBPF implementation.
I really love that, because in the end, you're trying to solve a problem in a different way. And that's great also because everything is open source. And this is what I really love regarding open source, because we got a problem and we got many actors that are trying to solve in a different way. So absolutely, I'm really happy to hear this answer. But we got also another question, one last question, but please, Neil and John, continue, because I'm pretty sure that Prasad is happy to answer all your questions. One last question. Yeah. Can you explain in brief how quality of service profiling works in the slices?
Yeah, so there are two in Nilanjan, there are two ways of addressing, we use TC parameters around this thing, and then we also use token bucket, for inter-cluster connection. So you can set the bandwidth, what you want to go. So typically what you are looking at from an edge standpoint, you don't want to inundate a whole bunch of traffic there. So you want to throttle it. Or you want to allow certain set of things. So there is a token bucket implementation, which is on the interface, which is going towards the cluster. So those are all the foundational things which we built in the QoS. Not only that, right? Where is the chattiness, right? So on the slice, you want to dedicate a certain set of workloads to a specific namespace or to a specific slice, so that your node network, which is actually egressing for all your pods, right, on a specific node is isolated. So that way you also enable certain set of QoS with respect to inside a node and as well as across the clusters. I hope that answers your question. Yeah, so what I would say is, if you can join the Slack channel, I will show you some examples on the interfaces, and then we can have lots of discussion. Thanks.
Yeah, keep in mind, Prasad, that we are going to upload this recording also on our YouTube channel. We are going to share all the links to KubeSlice documentation, open source code, and also Slack in the Meetup event page. And gentlemen, I think that's all. And thank you so much, Prasad, for the demo. It was really interesting and challenging, I'd say. And it seems so easy using KubeSlice. So will be worth to give it a try. And thanks all the peeps that joined from Avesha and also for the support, because I saw that Tanisha answered the questions. So thank you so much, guys, and have a nice day.
Thank you very much. And once again, Marcelo and Dario, thanks for inviting me.
Thank you so much, Prasad. It's been a pleasure for us and our community. We hope this is the first of many occasions that we can share a webinar together.
Yeah. Thanks, Nilanjan, for your questions.
Thanks. Bye-bye.
Thank you, everyone.
Thanks, everyone.